All right, so today in class we did a lot of review of chemical changes, and we did a short lab looking at how mass is conserved in a chemical change. And we're going to start looking at this thing called the law of conservation of mass, which applies to what we're about to start, this new unit, Unit 6, called Chemical Reactions. And this is our last unit for chemistry, and then we're going to move into physics. This is kind of the big unit that will lead you into being ready for high school chemistry and kind of tying all the things we've been talking about with chemical changes. So just reviewing really quick concepts. A chemical change where we have new substances being produced, which is going to be really important. It kind of centers around this whole unit that we're about to start talking about. We're going to break that down and look at what an actual chemical change is. Some of the things we need to review, if you need to spark your memory, go look back over at your old notes. Atoms, mass, atomic mass, and then chemical changes are really, really important. We need to look back over that evidence of chemical change. Chemical changes, what we looked at in our quick lab that we did today with the bag and the antacid tablet. And that we saw a gas being formed, bubbles being produced, sometimes a smell or precipitate, right? When a solid is formed during a chemical reaction can all kind of clue us in that yes, a chemical change has occurred, that a new substance has formed. So those are going to be some of the things we need to really review. We talked about how chemistry really builds upon itself, and that's really important. So this first lesson that we're going to look at in Unit 6 is called Describing Reactions. So before we can actually look at different reactions, we need to learn how to describe them and understand what we are showing in an actual chemical change, a chemical reaction. So a useful way of describing a change is to state what is present before and then what is present after, and that's where we're going to be looking at is a change, right? What was there first, and then a change occurred, and now what is there at the end. So a good example of this is to say like burning charcoal. So say you're about to have a fire, right? You're going to grill out, so you have your grill with your fire going, right? And you're going to burn those little clumps of charcoal, right? And when you do that with heat and light, burning, right, is a chemical change. We talked about that. That was one of our examples a long time ago. A substance is undergoing this chemical change, the substance being the charcoal, and it's going to become something new. It's going to react with oxygen in the air, and we're going to get CO2 produced, and lots of different new substances at the end of that. So we're going to look at chemical equations first, because one of our goals in the end of this is going to be able to balance a chemical equation. So in a chemical reaction, new substances are formed. New products are created. So just like my example over here with my burning of coal, right? We had coal to begin with, we burned it, right? A chemical change occurred, a reaction, and then new substances were produced at the end, like carbon dioxide. All right? So we have two parts in our equation. We have our reactants, right? And they are going to then give us, after our change, our products. All right? So that's kind of our formula right there for everything. On this side is always going to be our reactants, what goes into our chemical equation, right? Our chemical reaction, what happens before, right? And then what do we get out of that equation? What happens afterwards? Right? It's kind of like baking a cake. So we have all of our ingredients, our reactants, and then on the outside is our outcome, the final product that we get, which would be a cake in that example. All right, so reactants are the substances undergoing change. So they are what is actually going to be changed in the reaction. And products, these are good vocab words, are the substances that form as a result or because of, right, the chemical change. Okay, so this equation, an equation is used, this one right up here, reactants make products, right? An equation is used to represent a reaction by telling us what the reactants are and what the products are. All right, so an equation is used to represent a reaction by telling us what the reactants are and what the products are during that change. So our good example here, if we look at that one again from my fire up here, burning coal as a word equation, and if we're using words to describe it, that is carbon plus oxygen, giving us carbon dioxide, right? So we put these products in, carbon and oxygen, right? Carbon, the coal, oxygen, the air, right, around us, right? And then we have that heat that goes into it, and then during that reaction, that change occurs, and we get carbon dioxide. Right, so now we're gonna come in with that actual chemical equation, right? Some of the compounds that we've been talking about, and here we're gonna add them in. So as a chemical equation, right, so we had our word equation, and now we have our chemical equation, the same example, all right? So we have carbon, right? We know the chemical symbol for carbon, plus oxygen gas, O2, so two oxygens combined together, and you should know what kind of bond that is, covalent, right, gives us carbon dioxide, CO, right? I have to make this capital to show that I have carbon, oxygen, right, and gas that are created now in another compound all together. When I show them like that, I show that they are combined. Here they are separate reactants, and now they have reacted to form carbon dioxide. All right, so to review, a chemical equation tells us what reacts and what gets produced in a reaction. All right, so that's it. So review some of these things. I know it's been a while since we talked about atoms and mass and atomic mass, right? All of these things, and we talked about chemical changes a long time ago, so that would be a good review to look back over if you can't remember some of those big ones. What is chemical change? What is evidence of a chemical change, right? And we're going to be using these chemical equations. In our next few days, we're going to be learning how to actually balance some of these equations and make sure that what we are putting in, we are getting the same amount out, right? We are creating new substances, but we're going to talk about that we are not creating or destroying matter, all right?